Good day, ladies and gentlemen of trigonometry and pre-calculus aficionados, fans. This is going to be a guide to verifying trigonometric identities. And in the course of this video lesson, we're going to make these 4 transformations of identities, and we're going to proceed from the more complicated side of the equation on the left to try to get to the more simplified right side of the equal sign. So these are going to be problems we're going to be working out. So these are verifications where you're already given a target on the right side, as opposed to problems like this one where we're being asked to use basic identities to simplify an expression. Now in this case we are not given a target, so I find that these 4 problems where you're given a target to verify toward are easier in general than ones of this nature. But this last one I'm going to have worked out at the very end of this video lesson, so stay tuned for that. Before going over these 4 verification exercises, we're going to just review a guide to verifying these identities. Rule 1. These are rules of thumb. They don't have to be followed in every instance, but just generally. 1. Work with one side of the equation at a time. It is often better to work with the more complicated side first. 2. Look for opportunities to factor an expression, add fractions, square binomial, or create a monomial denominator. 3. Look for opportunities to use fundamental identities. Note which functions are in the final expression you want. And we're going to do that shortly, going over the key identities that are going to be our toolkit for this. 4. If the preceding guidelines do not help, try converting all terms to sines and or cosines. And we're going to do that a lot. And lastly, always try something. Even the paths that lead to dead ends provide insights. Now I find these problems to be pretty rigorous for pre-calculus students, and because you're not really given the guide of where exactly to go. So we're going to try to build, as we get through these exercises, intuitions about what to do. And let's go over some key identities. One thing that some use is a magic trigonometry hexagon. And so you have this hexagon with these 6 corners labeled with the 6 basic trigonometric ratios. Well, one thing we can do is we can take this sine squared x plus cosine squared x equals 1. So that creates this one here, sine squared, I'll say theta, plus cosine squared theta are equal to 1. And next we can take these other ones here, the tangent squared theta plus 1 equals secant squared theta. So tangent squared theta plus 1 equals secant squared theta. And then the last one here we have is 1 plus cotangent squared theta equals cosecant squared theta. So 1 plus cotangent squared theta equals cosecant squared theta. And then this also identifies other ones. And then we have this table that shows basic reciprocal identities. Sine theta equals 1 over cosecant squared theta, and so on. We have the Pythagorean identities, as previously mentioned here, that I've already drawn out. And then there's also something we like to call a tangent identity, which is going to be tangent theta is equal to sine theta over cosine theta. And similarly, cotangent theta, and cotangent theta being the reciprocal of tangent theta, is going to be cosine theta over sine theta. So let's go ahead and do these 4 problems now as advertised. So we have the first one here, secant squared theta minus 1 over secant squared theta, and we're going to go toward getting sine squared theta. Well, we're going to work with the more complicated side first, which is the left side. And so for that, what we're going to do is use, I'm going to go back to this identity, the secant one. So we're going to have 1 plus tan squared theta equals secant squared theta. So 1 plus tan squared theta equals secant squared theta. And if we subtract 1 from each side of this identity here, we get tangent squared theta equals secant squared theta minus 1. Well, what do you know here? We can take this secant squared theta minus 1 and replace it with tangent squared theta. So we can rewrite this original expression on the left side, and I guess what I'm going to do is kind of leave the equal sign over here on the right. And so what we have is, in place of secant squared theta minus 1, we have tangent squared theta, and that's going to be over secant squared theta. And so now we're going to continue to simplify, and we're going to, at this point, we're going to change things in terms of sine and cosine. So the first thing we're going to do is take tangent theta is going to be equal to sine theta over cosine theta, and also the secant theta is going to be equal to 1 over cosine theta. We're just pulling from our list of identities. So just rewriting this in terms of sine and cosine, what we have is sine squared theta over cosine squared theta. And so that's just tangent squared theta rewritten. And then on the bottom here we have 1 over cosine squared theta. And now what we have is dividing by a fraction is the same as multiplying by a reciprocal. So we can rewrite this big fraction here as sine squared theta over cosine squared theta. So instead of dividing by 1 over cosine squared theta, we can multiply by its reciprocal, which is cosine squared theta over 1. Well, just kind of going to the right here, we have cosine squared theta over cosine squared theta will cancel each other. So we have left sine squared theta over 1, which simplifies to sine squared theta, which is our original. So that equals, so we have that equals that, equals that, equals that, and finally we arrive at sine squared theta. So let me just put an equal sign here. So that's all there is. And just to be clear about this, the working out of the problem is not this bottom finalized one that we came up with originally. It's all this work on the left side, the more complicated side. That's where the essence of the work for the problem is done. Let's go to the second sample problem. And I invite the viewer to, if possible, if you can go ahead and write these out, try these first. So we have the second one, 1 over 1 minus sine theta plus 1 over 1 plus sine theta equals 2 secant squared theta. Well, in this case, what we're going to do is we're going to try to simplify the one on the more complicated one on the left. And what we're going to do is something called multiplying by the conjugate. Well, the conjugate is where we're going to multiply this 1 over 1 minus sine theta, and the conjugate of 1 minus sine theta is 1 plus sine theta. So we're going to multiply the denominator of this first fraction by 1 plus sine theta. And having multiplied the denominator by 1 plus sine theta, we need to do what in the numerator? Multiply also by 1 plus sine theta. And then for the second fraction, we add here, we have 1 over, we have 1 plus sine theta, and we're going to multiply this 1 plus sine theta by its conjugate, which is 1 minus sine theta. And then correspondingly, we need to multiply also our numerator by 1 minus sine theta. And one characteristic of working out these types of problems, often we're going to devolve into what looks like more complexity in the hope of eventually getting to a more simplified version, like on the right side of this equation. So that's just a feature of this. Now, multiplying these, we're going to multiply through here on the denominators, and when we get quantity 1 minus sine theta times quantity 1 plus sine theta, we're going to get 1, and when we multiply negative sine theta times 1 and positive sine theta times 1, these are going to, in our denominator, cancel out each other. So what we're going to be left with is 1 minus sine squared theta. And so that has simplified things a bit, and in our numerator we have 1 plus sine theta. Okay, and then we add this here, and then similar to our first fraction, we multiply the denominator of this right fraction. We're going to similarly get 1 minus sine squared theta. And then in the numerator, we have 1 minus sine theta. And just continuing to work below, we have in our two numerators, see we have a common denominator at this point. So let's go ahead and take care of our two numerators here. In these separate fractions, we have sine theta minus sine theta, which will cancel to be 0, and then we have 1 plus 1. So we're going to have left 2 over 1 minus sine squared theta. So we have a lot more simplicity, don't we? And now we're going to pull out of our hat this trigonometric identity, which is the primary Pythagorean identity, which is sine squared theta plus cosine squared theta are equal to 1. And so if we subtract sine squared theta from both sides of this equation, what we get is cosine squared theta is equal to 1 minus sine squared theta. So now we can replace this denominator below as with 2, see we have 2 over, and we replace 1 minus sine squared theta with cosine squared theta. And it so happens that secant theta is equal to 1 over cosine theta. That's one of our reciprocal identities. So therefore, just equaling to the right, we can rewrite this as 2 secant squared theta, which is what we targeted originally. So we expanded and got more complexity initially, and then we eventually were able to reduce down until we got our target with what was originally on the right side. And all the work here is the problem worked out as opposed to just circling the final conclusion. Okay, next, problem 3. Let's go and look at this. We have a lot of things here, don't we? How are we going to do this? We want to eventually work out all this stuff on the left and have it end up being what's on the right. What is that going to be? Well, let's go ahead and take a look at this. I'm thinking that what we're going to want to do on the top side here is replace with cosecant squared theta. So cosecant identity, or cosecant theta, is going to be equal to 1 over sine theta, one of our reciprocal identities. And similarly, our cotangent theta is going to be equal to cosine theta over sine theta. So we're going to simplify that. And last thing is we're going to take this tangent theta, that's going to be equal to sine theta over cosine theta. So we're going to take this original expression here on the left side and change out everything using these 3 identities at the right. So just rewriting in our numerator cosecant squared theta, that's going to be transformed to 1 over sine squared. I said theta, we're going to make this x. And then we're going to take minus cotangent squared x, which we're going to rewrite as cosine squared x over sine squared x. And so that's rewriting that whole numerator in the original expression. And then we're going to rewrite this tangent squared x as sine x, or sine squared x over cosine squared x. And then times, we're going to rewrite cosecant squared x as 1 over sine squared x. And now we look for things that we can simplify. Well, in the denominator, we have this sine squared x over sine squared x. We can cancel each other. And in the numerator, we have a common denominator of sine squared x. So rewriting our numerator, we're going to be left with 1 minus cosine squared x over our now common denominator numerator of sine squared x. And rewriting our denominator, what we have left after canceling in the denominator sine squared x over sine squared x, we have left 1 over cosine squared x. And what we have for this 1 minus cosine squared x, if we go to our palette of trigonometric identities, we have sine squared theta plus cosine squared theta are equal to 1. So if we subtract cosine squared theta from both sides of this identity here, what we have is sine squared theta is equal to 1 minus cosine squared theta. So therefore, we can replace and now I'm just going to work to the right here. In this numerator here, we're going to replace this 1 minus cosine squared theta with sine squared theta, or sine squared x. So now we have left on the numerator sine squared x over sine squared x. And in the denominator, we have 1 over cosine squared x. Well, what we have is secant. Since we're actually going toward getting cosine squared x, I'm just going to leave that alone because that's where we're trying to get. So we're going to write this as 1 over cosine squared x. And what we have here, and just continuing to work to the right, we have 1 sine squared x over sine squared x is going to be 1 over 1 over cosine squared x. And now I'm just going to continue below here. Dividing by 1 over cosine squared x is going to be the same as multiplying by cosine squared x over 1. And they will cancel each other, so we are left with cosine squared x, which is our target expression on the right side. Again, a lot of work. We complicate things by changing to all these terms in terms of sine and cosine, simplify, use common denominators. So all these identities on the right are the ones that we use. Okay, the last one we're going to look at here is tangent x plus cotangent x equals secant x cosecant x. And in this case, it's hard to see which one is the more complicated version, but we have 2 terms on the left and 1 term on the right, so we're going to assume that we're going to work with the left side, which is our more complicated side, by virtue of the 2 terms. So we're going to use the tangent and cotangent identities. To remember what they are is tangent theta is going to be sine theta over cosine theta, and cotangent theta is going to be equal to cosine theta over sine theta. So let's just go ahead and rewrite this. On the left side we have sine theta over cosine theta plus cosine theta over sine theta is equal to whatever we have on the right side. I'm not going to put an equals. Yeah, I guess I will. Okay, we want to have a common denominator here. So we're going to go for the common denominator of cosine theta, sine theta, and to do that, our first fraction here, sine theta over cosine theta, we're going to multiply by sine theta, and then we have to similarly to make up for multiplying the denominator by sine theta, we need to multiply also the numerator by sine theta. So we have that, and for our right fraction here, we got to take our cosine theta. Now I'm using theta here instead of x. They are really interchangeable, so not having spotted that earlier, that's fine. And then we're going to have to use our common denominator. We're going to multiply our denominator by cosine theta, and similarly our numerator by cosine theta. So what we have left is sine squared. I'm going to make this x now, this sine theta times sine theta, and then plus we have cosine theta times cosine theta. I'm going to call this cosine squared x, and then we're going to have this over cosine theta, sine theta, which is our common denominator. Well, our major Pythagorean identity is this one here. Again, sine squared theta plus cosine squared theta are equal to 1. So we can replace this sine squared theta plus cosine squared theta with 1. So we have 1 over cosine theta sine theta. And now what we have here is that secant theta is equal to 1 over cosine theta, and similarly cosecant theta is equal to 1 over sine theta. So therefore, again, I'm getting my x's and my mixed up here. It's easy to forget. And similarly below. So we're going to replace this 1 over cosine x with secant theta, or secant x, and this 1 over sine x with cosecant x. And we've arrived at our target now. So again, a lot of work, expanding out and eventually simplifying. So that's basically those exercises. Now we're going to get to the very last thing I'm going to show you is the working out of that one problem I showed you earlier, this 1 plus tangent squared x over cosecant squared x, and basically the use of these identities to arrive to the simplification here at the end, at the conclusion of tangent squared x. So that's it. A guide, basic guide to verifying trigonometric identities. I hope this has been helpful to you. Good luck, and thanks for viewing.